So the first and most common form of energy that we are going to talk about today is that of fossil fuels. The definition of fossil fuels is that they are a non-renewable energy source that are dug up out of the earth. Non-renewable means that it's a finite resource that cannot be replenished in our lifetime. So once we use up all the fossil fuels on earth, they are gone for good. Fossil fuels come in three different forms, that of oil, natural gas, and coal. Both oil and natural gases are made up of hydrocarbons and are fossils of marine planktons. It was a common misconception back in the 80s that fossil fuels came from prehistoric dinosaurs when they actually came from prehistoric microorganisms. This misconception came about due to the fact that gas stations would feature a dinosaur as their logo. And lastly, there's coal. Coal is a solid material that is made up mostly of methane and comes together when terrestrial plants are compacted and condensed. Now I'm going to talk about the extraction of different fossil fuels. The way petroleum and natural gases are extracted is through the drilling of wells. Petroleum wells produce around 6 barrels of contaminated water for every just 1 barrel of oil, meaning that this water must now be properly stored somewhere where it will not contaminate surface water or groundwater. Offshore drilling for oils has now become more popular due to land oil wells becoming more scarce and drying up. Some non-conventional sources of oil include oil shales and tar sands. These type of oil sources are more expensive, more difficult to extract, and have an even higher environmental risk than just conventional oil drilling. It also has a lower net energy yield. Some non-conventional sources of natural gas are typically found in shale deposits and use fracking to extract them. Fracking is a process where water is pumped deep underground and where it fractures surrounding rock, which releases the natural gas. Some of the natural gas will escape into the atmosphere before all of it can be captured, making this sometimes not the most efficient process of doing so. So what are fossil fuels used for or used to make? All of the objects that you see below were made using some type of fossil fuel, and each of these is an example given from our textbook. So basically anything that's made of plastic like credit cards or paints are automatically using some kind of fossil fuel or more specifically oils. But surprisingly, there were some other products that I didn't even expect that would have fossil fuels in them, such as lip balms, shampoos, glues. Artificial vanilla extract was really surprising. There was also shoes, and vitamin capsules surprisingly have fossil fuels in them. Out of curiosity, are there any other products that you use in your daily life that were produced using fossil fuels? And if so, do you think there would be any better ways to reduce or stop using these type of products entirely from your life? Just something to consider. So, some environmental problems that are associated with fossil fuels. First, we're going to talk about that of coal mining. Coal mining results in the destruction of entire mountains, the burial of streams and valleys, and produce huge quantities of contaminated waste, as we discussed a little earlier in this PowerPoint. There are also that of ocean oil spills. In 2010, the Deepwater Horizon spill in the Gulf of Mexico resulted in the deaths of thousands of creatures. The overall impact of this spill on the environment as a whole is still unknown. There have been other oil spills throughout the last decade, and all of them have caused similar environmental concerns. Not to mention that at first the oil floats on the surface, as you can see in this picture, but eventually it sinks down before anyone can clean it up. So it really, who knows how much oil is down there. There is also that of the fossil fuel pipelines. Spills and accidents can occur with around 2.2 million miles of pipelines in the US alone that transport these fossil fuels. This can occur when maintenance gets overlooked in some places, pipes corrode, or when people with no connection to oil companies dig where the pipeline is. This might be a little confusing because this pipeline you see here is above ground, but they also have underground oil pipelines that you can't see. Now I'm going to talk about some energy data. The International Energy Agency, or IEA, is an intergovernmental organization that represents 28 countries, including the USA. They act as an energy policy advisor to the Organization for Economic Cooperation and Development, or OECD, which is a group of 30 democratic governments combined. The IEA also publishes its own data, projections, analysis, and statistics of the amount estimated of the world consumes of different energy sources. This is an annual document called the World Energy Outlook. You can actually find this online if you're curious about world consumption of energy sources. Here in the United States, we have the U.S. Energy Information Administration, or EIA. It's an agency within the U.S. Department of Energy that is charged by Congress to provide energy data, analysis, and projections. They also publish the International Energy Outlook reports annually that are more specific to the USA. It shows energy consumption by country, by fuel type, and by sector. Now we're going to talk about renewable energy. The definition of renewable energy is that they are energy sources that do not deplete or can easily be replenished within our lifetimes. Examples of sources where renewable energy can be obtained include sunlight, wind, waves, geothermal heat, and biomass. The best way to practice and apply renewable energy sources is to use less energy by increasing efficiency. Now, for instance, what I mean by this is by changing the way our buildings are built, how they're heated, how they are cooled, how they are lighted, is one of the many ways to just start becoming more efficient as a society. There are also enhancements in technology like electric cars that are also helping us to become more efficient in energy usage. Centralized and distributed powers. Just about all the electricity in both Europe and the United States are distributed through massive centralized power grids. With these grids, energy can be transferred from region to region or wherever it is needed. It also enables power to be delivered to cities from power sources that cannot easily be moved, such as wind farms or hydroelectric dams. Power that's generated from some kind of power plant is usually centralized, but it can vary, and is generated by sources such as coal, natural gas, and nuclear reactors. Distributed powers come from small on-site generating equipment and is used close to where it is produced and tends to be renewable energy sources. Examples of distributed power include industrial plants using combined heat and power, and/or a homeowner producing their own energy with rooftop solar panels. Solar photovoltaic panels. When asked about reusable alternative energy sources, we typically think of solar energy first. Solar panels are made from photovoltaic or PV cells. These solar cells are semiconductors that are what convert sunlight to electricity. Solar power was first invented and used in the space program in the 1950s to generate power for satellites in space. Now, unfortunately, costs to buy solar energy systems are relatively high, which can deter individuals like you or me from buying them. While chemicals are used during the manufacturing process of solar panels, once in operation, they emit no pollution and no greenhouse gases, overturning the fact of the initial usage of chemicals. So it tends to be a trade-off of high monetary costs versus the environmental costs of still burning fossil fuels for energy instead of using solar power. Geothermal power. Heat from the Earth comes from three different sources: residual heat left from violent collisions that formed the planet, radioactive decay, and the tremendous pressure deep in Earth caused by gravity. Geothermal power could be generated off these heat sources. Currently, areas with tectonic plate or volcanic activities are the only places capable of even harnessing geothermal energy. For example, Hawaii with its volcanoes that produce lava. When the lava reaches the water, it creates steam or hydrothermal activities that can be used to create geothermal energy. Research is still ongoing to find ways to provide better geothermal power everywhere, possibly by drilling deep wells and pumping water down to the hot rocks to create steam. This, however, is not yet available for commercial usage.